Hello.
Hello, good morning.
Good
Sir, can
morning,
we
ma.
start? Sir, start
Yes, ma.
பண்ணலாமா sir?
Yes, start பண்ணுங்க, ma.
Thank you, sir. Good morning, everybody. In the name of Almighty, we begin this first day of the induction program Tender Feet 2020 with the recital of Kirat by Bashratullah of first year ECE. Bashratullah, you can recite the Kirat.
السلام عليكم ورحمة الله وبركاته. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. ألم تر كيف فعل ربك بأصحاب الفيل يذهم في تضليل وأرسل عليهم طيرا أبابيل ترميهم بحجارة من سجيل فجعلهم كعصف مأكول. صدق الله العظيم. Meaning, in the name of Allah, most gracious and most merciful. Have you not considered how your Lord dealt with the people of the elephant? Did he not make their plot in vain? And he sent down on them birds in flocks, striking them with stones of baked clay. Then he made them like straw eaten up. Thank you.
Thank you. Now we have Tamil Thai வாழ்த்து. Now, I request our beloved Principal, Dr. K. S. Srinivasan, to deliver the welcome address.
Good morning. Good morning, my dear students and parents. It is great pleasure for me to welcome you all. Hello. Good morning, my dear students. It is great pleasure for me to welcome you all for this Tender Feet 2020 induction day of family. First of all, I would like to congratulate all the students as well as parents for choosing this college for pursuing your career pathway. So, Muhammad Sadaq College of Engineering established in the year 2001 under the aegis of Muhammad Sadaq Trust and is affiliated to Anna University and approved by AICTE. Our trust has 46 years of excellence present in engineering education sector, offering technical, arts and science, medical, management education. Muhammad Sadaq College of Engineering was established with an objective of imparting quality education, developing ethical values and personality traits thereby molding the budding engineers into dynamic and deployable engineers. The college is located in a less green even IT within Sipcat IT Park and is surrounded by the top 100 plus multinational IT industries such as TCS, CTS, Infosys, HCL, Aspire, Hexaware Technologies, Intellect, etc. Muhammad Sadar KJ College of Engineering offers 6 UG courses and 2 PG courses. And the college has a ample infrastructure such as a classrooms, laboratory with state-of-art facilities. In addition to that, even industry-oriented technology centers, 20 centers established to develop the young budding engineers to meet the industrial requirements. So the centers are like industrial robotics, 3D printing and additive manufacturing, embedded system and IoT, humanoid robots, building information system, robotic process automation, Cisco networking, solar and wind energy, Center for CAE, augmented reality and virtual reality, LabVIEW Academy, etc. So the college has a wide scope for excellent personality development program through various professional associations, curricular and co-curricular extracurricular activities, and students are encouraged to participate in various student chapters like in IEEE, CSI, ISTE, IETE, SAE, ICT Act, NSS, ORC, etc. So college will be providing all-round training the students to have that of the academic excellence, team spirit, time management, money management. In all these activities, they will be giving that of hands-on training for you. In this induction program, for the next 2 days, various experts are likely to interact with us on this today's in this session. Many eminent personalities like Ms. Vaijayanti, strategic planning and executive management leadership, complex project management from IBM, Dr. Lakshmi Narayanan, technical manager from Decentech Systems, Mr. Jayakumar, an expert from the VLSI industry, Dr. D. Sunil Kumar, postdoctoral fellowship from IIT Bombay, Mr. M.R. Krishna Kumar from 3D image processing and solutions for the medical applications are available with us to interact and give that the guidance how to proceed for the next 4 years and what all that the domains will be having that of more popular in that of the industry and the demand is there in the industry. They will be giving that of the input for you. Feel free to interact with them and gain a knowledge and how to develop at all. So the next 4 years, you may have that other pleasant stay with us. Even very soon, we'll be meet in a person in that other campus. We'll all pray for that. We'll have to come out of this pandemic situation, and the regular classes will may resume from that other from 2nd November. So the next 3 days, so like this kind of an induction activities, even various industrial experts and other persons are now likely to interact with you and make comfortable yourself, attend and gain the knowledge. Thank you very much. All the best.
Thank you, sir. Now it's a pleasure to introduce Ms. Vaijayanti Srinivasa Raghavan from IBM Global Services India, Bangalore. She received her bachelor's in engineering from University of Madras with University First Rank. Her master's was in business analytics from BITS Planning. She is an IBM certified delivery project executive with 26 years of experience in project management, consulting, vendor and knowledge management. She is an accomplished public speaker in industry forum, an author of bestseller Shape IT. Presently, she is the top performer in the current organization with wide range of work experience. Madam, it's an honor to hear from you this morning. Thank you.
Thank you so much, Sai Priya madam. First, let me start thanking few people in the call because I did see some of the known faces, be it from your principal, Manju madam, and I was really surprised to see principal sir here today because we have worked in a different capacity. So thank you for having me over here, sir, today.
Thank you, ma'am.
Thank you, Manju madam, for reaching out to me and giving me this opportunity. And another surprise is Sai Priya madam. We are schoolmates, and that was another big surprise, right? I feel so elated to be part of this platform. There is a fourth interesting thing about this college, which not many of them know. My grandfather, who is no more, the late Professor N.S. Rajagopalan, he was associated with the Kirakarai College of yours for a short period of time. He was a professor of physics, and he worked with Professor M.K. Venkatraman in those days, who has written the mathematics book. So it's a very pleasant moment for me to be associated with all of you today in this platform. And I see 20 people, 21 people in the call in this, and I think YouTube streaming is happening. So to all the viewers who are watching this session, we will keep it for 30 minutes, and then I will open it up for question and answer. We'll have it as more interactive session. So before I flash my presentation, I want to tell each of the students who have joined this institute, you have made the right step in your journey of education. Eventually, you will be getting into the right step into the career as well. Thank your parents who have taken the time to enroll you into this education and made you what you are. Show them all the gratitude as to what you are, and they have put in all their efforts in shaping you to the person what you are today. And one final thanks to one gentleman, Mr. Basharatullah, who sang that hymn from the Quran, I guess so. And I think thank you so much for explaining it so well and setting the context and taking us through that prayer as well. So thank you once again. So let me get started. Sai Priya ma'am, just give me a okay if you see my presentation, then I'll get started. Okay, I'm going to share my screen, and then you can let me know. Okay. Are you able to see it, Sai Priya ma'am? Just give me a okay, or then I'll get started.
Yeah, it's visible. We can see the screen.
Perfect.
We can.
So to all the audience who are listening, including the parents of the students, welcome to this session and a wonderful theme called Tender Feet, right? And when I was looking at the Tender Feet, the theme of it, I was really elated because it speaks so much. What is this? What is a tender feet? When you step into from the school to the college, you really do not know what you're getting onto. So many unknowns are there. You are really tender in every aspect. This 4 years of journey that you're going to have with the college is going to mold you and make you more resilient. And that's exactly what I think principal said it loud and clear. We'll make this journey joyful. We'll make
Excuse
it more
me, ma'am.
experiential learning for you. Yes.
Excuse
Can you
me,
hear
ma'am.
me, ma'am?
Yeah,
Yes.
I'm able
Can you
to hear
hear?
you. Can you please make it full screen?
Yeah, we'll do that. Just a minute. Let me do that. Okay. Just tell me if you are able to see it. I know why you're not able to see full screen. There is a reason that I would, yeah. Can you see it? Now it's also not full screen, right?
Yeah.
Yeah, the layout of the presentation is not full
Now
screen.
it's clear. Thank you. Okay, thank
Yes.
you. Thank you.
And I wanted Sai Priya ma'am to ask this question because the theme of today's session is also perfect to be imperfect, right? So that is, if you look at my presentation also, it is not perfect. Everybody would have assumed it's going to take the entire screen. No, I made it more imperfect. There is a reason for it. And you're all getting into this journey of college. What are you supposed to be doing in 4 years? You're not going to be a perfect of somebody else. You're going to be a imperfect person, but perfect of yourself. That means you have to be what you are. That's going to be the theme. Now you might be wondering, what is this Vijay? My call name is Vijay. What is Vijay talking about? She just put a bowl in the presentation title. What exactly does that mean actually? Now you see the bowl, it's a very interesting concept. I wanted you to walk you through this concept and then tell you what it means in your engineering journey. If you look at it, this is an art that was called as kintsugi. Kintsugi is a Japanese art. It's called a golden joining. That means in good old days, There was a king in Japan in the 15th century, and he had a shogun. Shogun is nothing but a person who is in the highest order of military reporting to a king, and his name was Ashikaga. And they got ceramic ware from China. So the tea ball from China are very famous, so they got it. And it's very fragile. You know, the ceramics are always fragile. It used to break. So then they sent it back to China to get it repaired. What they found was the surprise was whatever they sent, it came back with the multiple staples on the ceramic. You can staple the ceramics also. So then they said there is no point sending it back to China, getting it back with a bunch of staple on my teacup. So that they decided to make something out of it, and what they call is an art. The art called kinshugi. That means you can break something and you can create something completely new out of it using lacquer and the golden paint. That is what is called as kinshugi. And this is a great motivation for many people, because what Japan has found out is there are many things that you get from your ancestors, which might be ceramic, and you have an emotional bonding with it. By mistake, you break it. You don't have to feel bad about it, and you can assemble using this technique and make completely something new, and you don't feel bad about what has happened, right? You've completely given a new shape to it. That's how this art was formed. But over the 17th century, what has happened is this became a very common technique, and today this is being taught as one of the craft in Japan of how do you really make different kind of newer ornaments and different cups of shape, completely different. I would say you would have possibly bought a teacup, but you can convert it into some other figurine. So you can do various things with this, right? So why am I really talking about it? The next 4 years of journey, though you are having a tender feet, you will come across a lot of cracks in various ways. Why do I say that? I'm not threatening you. I'm not scaring you. It is going to be 4 years of the journey, which is all going to be by learning, by doing. That means the more you use your hands-on, the more you do, you're going to come across something that you are not even aware of. You're going to create something new. You might be thinking this is the way of doing. You might be thinking somebody else did it, so I have to do like this. No, you have to be the person who have to create something that is more meaningful for you, and not try to benchmark yourself with something that is already existing. So this Kinshugi has set a very beautiful context. Even in the management schools, they teach people of how to be yourself, what you have to make a sense for yourself, whether you're studying, whether you are at work, whether you're at home. How do you really be authentic you? That is what it means. Now, having said this, I want to take you to some of the fundamental things. One question you will be asking, why did I even join engineering? People will be asking, if I ask most of you in this call, you will say, my parents told me to join, so I joined. No, don't do that. If you have joined, then what engineering has got to offer? Engineering are connected using different elements. The first is the science, the next is the society, the nature, and technology. It's all give and take between these 4 elements, and that constitutes the engineering. So what exactly do we do in engineering? Whatever is around you today, you take your watch, you take your items at home, maybe your iron box, whatever it is. It was all born out of the necessity that the society wanted. There is a society with which the engineering always interacts with. The first element that you will interact with the society, because they are the one who are going to use what is the outcome of this engineering. The second big element that comes in engineering is your science. You must have thought, I don't need to know science, I don't need to study something, come out of it. You will have to know the fundamentals of your physics, you must have studied chemistry, whatever you've studied, even today, your biology, what you studied in college, zoology, all are going to be used in engineering, because today the engineering is just not about IT, computer science, mechanical, or civil, or triple E, or ECE. It's much beyond that. So the second element is going to be your science. You're going to borrow some of the theories that you have studied in the science, and you're going to apply in your engineering, and you will start using them in producing something that is meaningful to the society. But there is a beautiful thing that has happened in the last many years. We have a lot of technology tools that are already available. You're going to borrow some of that as well when you create something. So that is the tools that you're going to borrow from this technology. But interestingly, that is not the only thing. You're going to use some of the resources from the nature too, right? So the resources could be your people are developing things for the petroleum industry. There are people something developing for your education industry, their agricultural industry. So all this, what you're doing is something related to nature. It's just not the society you're looking at. You're also looking at the nature aspect as to what you can borrow from there and integrate as a use case within your engineering, and that you make it as more meaningful for the society. If you look at this diagram, one thing you will realize is the output that is coming out of engineering is all consumed by the society, right? This is the only output. The rest are all the input that is coming in. Just keep in mind, whatever you're doing today in engineering, it is some way has to positively impact your society. That is when you're doing justice to the education that you are doing today or studies that you're doing today, right? Now, there are some call-outs I have done because people interchangeably think engineering is technology, technology is engineering. Absolutely not. There are two different things. So technology is all about the process, artifacts, tools that you have developed over a period of time, which we call it as process, knowledge, and body of knowledge. There are professional bodies that are existing. That comes under the technology. But engineering is all about what you build, what you design and maintain, and that is what it is. And that's why I was telling that it is all going to be learning by doing. You're going to come out of theory. You're not going to just look at the book and then keep flipping. Even you're doing online today, you're going to be given a lot of things on practical use cases to work on. So remember one thing, take this journey of 4 years with a joy and seriousness. Remember, if you fail to embrace this 4 years of journey with a joy, you are going to be finding it very difficult when you come into the job industry or a career. I don't use the word called job many times. I know some of the people know me quite well. The reason is career is something that you wish to make out of. Job is something that you work for money, right? You want to make a career out of your learning. That is what it is. You want to make it more joyful. So this is what engineering is all about. Then what exactly is happening in engineering? Today, interestingly, engineering, I want to just talk about myself first, then you will appreciate how fortunate you people are in this call. When we started our education, when I remember I joined my engineering, there were only 6 girls in the class of 50 students. Imagine the ratio of girls to boys. That is one. Second is, we didn't have disciplines that you are even hearing today. We had possibly 3, even computer science, IT were just not in some of the colleges at that time. We had civil, mechanical, triple E, ECE. Possibly these were the 4 branches that we heard of. We used to call this as multidisciplinary. That means each of them were there, but each of these disciplines were working on independently. There was no connections between anything at all. But over a period in the last 15 years, what we have seen, including my example I want to give of my son is doing his aerospace engineering. So when I was trying to get the admission for him around a couple of years back, I went through every college and I was really stunned by the kind of engineering discipline that was put in front of me. I was shocked. Can this engineering discipline be so many? And it is, you will not believe. There are 30 to 40 different engineering streams today. Even the AICTE, if you go through their website, you can find the details by college of the engineering disciplines that they offer. And now that has become more interdisciplinary. And this is the era that you are in. That means you will have the overlapping of engineering discipline from two different disciplines. That means if I am in a mechanical engineer and I am also learning robotics, combine it together, you have something, a beautiful thing called mechatronics, right? You have little bit of electronics, little bit of mechanical, little bit of robotics and computer science all integrated. You have a beautiful concept of mechatronics, right? So that is a new engineering discipline. Was it heard of 15 years back? Not so. Not many even knew about it. But today, the colleges where these interdisciplinary things even doesn't exist, there are some beautiful things that is happening. I'm sure this college also has that. We call it as competition-based learning. That means what? When you are in your 4 years of engineering journey, you are going to have competition held in colleges, inter-college competition, and the colleges are all going to be very different. I want to give you a small example. Everybody would have heard about hackathons. What is hackathon? Hackathon is a competition-based learning. Right today, big companies and corporates are looking for people. How you really do the coding, come up with a business case. They give you sometimes the problem statement, and then you go ahead and start writing and giving solutions. But in the hackathon, you can form a team. The team can be a one person from your electrical background, the other person could be from mechanical, and so on. So that is becoming an interdisciplinary competition-based learning that you will come across. The second example that we have seen in colleges are, you have ACA Baha. That means an automobile industry has come up with a beautiful concept where students in different work stream can build a small go-kart, small cars, and then they can demonstrate. What happens in the a mechanical engineer guy cannot work all by himself. He will need the electronic guy, because today most of your cars are having more electronic component than a mechanical component. And the third thing, you will see there'll be civil engineering guys also coming up. Why civil? Because you have to run it on a track, right? So you need to know how the conditions, road conditions can it perform, how is it need to be, so on and so forth. Look at the kind of interdisciplinary opportunities that you're having. We are saying that it is going to be the overlapping of the disciplines that you are in today. Now, interestingly, this is not where it ends. It's going to get more interesting in the coming era, I would say. We are going to see something called as the transdisciplinary. That means there is going to be a more and more, I would say, congregations of various disciplines and newer types of engineering concepts that is coming up. Would you even have thought of ML, machine learning? People are talking about, I talk to anybody, everybody speaks about machine learning. Would we even have thought of data is going to be such a big thing today? Everybody speaks about data. So that is the kind of era that we are moving. And I'm sure in the next few days, you have speakers from various other, I would say, industry come and speak to you about these. But what you have to note here is, if you are in the next 4 years, starting your first year, look out for opportunities in your college. Talk to your professors, talk to your seniors, talk to industry experts, have a mentor. You need to have a mentor, because the mentors are going to be a great help for you, because they will tell you what is happening in the industry. Have yourself enrolled in a professional body. That means if you want to IEEE, go ahead and enroll. There is today forums where you can, IRPAI, there is about the automation industry. They have a forum for that. So try to get into those kind of a professional body of knowledge. Some of them are completely free for the students. LinkedIn itself is a great platform. If you don't have your profile, the first thing that you're going to do, walk out of the session, create your LinkedIn profile. Start looking out for free webinars, LinkedIn offers. Look at what is happening in the industry, what the bloggers are writing about the industry. So your industry is becoming more and more transdisciplinary. That means you cannot say, I will only learn triple E, I don't care about programming. You cannot say, I will only learn mechanical, I don't care about electrical. You can't say, I will only learn the computer science, I don't care what happens in engineering, other engineering stream. You cannot say that. The reason is, today, even you come to work, people want you to be a person who knows some domain. Many times I talk to engineering students, they get confused between domain and technology. Technology is technical. Let's be very clear about it. Domain is related to business. If I say I'm in a retail domain, it is about the retail business. And if you apply technology to it, how you really enhance technology in that business. So domain plus technology is very, very important. By the time you come out of your final year, you need to be at least be aware of one domain, at least have a liking for one domain where you would like to work, either finance industry or your automotive industry, or it could be your healthcare industry, be it anything. You need to find that one passion of domain of yours and try and understand that. How do you understand the domain? Very simple. Go to some area near your house. Maybe go to your retail. If you want to know more about the retail industry, go to more. Go to Reliance shop. Just observe, walk around and see what exactly happens. How do they keep the product in the shelf? How the billing counter work? How they tag the products? Why do they have different layers? Why do they have women's section at the lower level and the men at the top? Could that have been a different? Why did they not make it different? And why did they have the utensils on the last floor? There are various reasons why they have done it. Try and understand point of sale. So these are something that you have to learn by observing. This will not be taught in engineering. This has to be learned by observing and learning by doing. So that is one key important thing I want to really call out. The next thing is that I was really talking about one other concept of discipline of future. Discipline of future is what I said. Look at the mechatronics. Just I want to leave you with one thought here and then I'll get into the next slide. The discipline of future, AICTE clearly says that to any colleges that are getting open or have existing colleges need to have an artificial intelligence, IoT, mobility, analytics, and cloud as some of the emerging credit courses or emerging courses in their existing curriculum. So what would that mean? You as a student will be asked sometimes by your faculty to do some of the massive open online courses. We call it as MOOC, right? These are free online courses that are available for students. You can enroll, you can learn about what is happening in these areas, and every course that you complete, you get a certificate. You can beautifully flash it in your LinkedIn. That's how you enhance your profile in the LinkedIn. So every college is you're going to come across in next 4 years. Your faculty coming to you and asking you to do some of these credit courses. Don't say no to it. Go ahead and grab it. These are opportunities which are beautiful, which will not come again, right? And similarly, for the faculties also who are listening in the call, we are also telling them to keep learning and upgrading, right? Don't expect the faculty to be perfect. It can't be, because the way the technology are changing is so fast. What was 2 years back will not be there in the next 1 year, right? It's just so different today. So every faculty is putting in the same amount of effort as you're going to put in. So there is going to be a collaboration between the faculty and the students. In many colleges, you will not believe there are after college programs where students and faculty have a meetup group and they share their knowledge. They don't really differentiate who's faculty and who's the student. And that is the way how things are going to be. The faculty are going to be more like the learner along with you in this journey. Remember that. So don't come and say, you know what, I don't like this person, she didn't answer the question. Nobody has the complete answer today, the way in which things are changing. But the fundamentals needs to be strong. You cannot be wishy-washy on the fundamentals. If your fundamentals are strong, then you're going to be perfect. Today also I remember V is equal to IR. How do I remember that? That's because that is the way my teacher taught me, when lecturer was teaching me when I studied my engineering. And there was a way how they used to teach, and that still is in my head. I know what is a lap winding, wave winding. How do I know these are all related to triple E? What I'm working on today is on computer science. Now, why do I remember that? These are all the fundamentals. You cannot forget the fundamentals. So that is one important thing. Discipline will change. It is going to become transdisciplinary, but the future is going to change for you. Newer work is going to come. Be aware of what is happening around you and start to learn along with the faculty, and faculty should learn along with the students. And more so, you should start realizing that the fundamentals need to be strong. The fundamentals are going to be the core for you. Now I'll come to this because this is one thing which is passionate. This is a book that I think Madam did speak about, because it's not promotion of the book, but this gives you a framework. I'm just holding the book and I'm here. So let me just talk about it. The Shape It was a concept or a framework. We call it as a trait. People came and asked us, hey, technology is changing. Everything is changing around us. How do we really need to be current and keep ourselves current? We went and interviewed around more than 100 to 150 students around Pan India. And this was the book as an outcome of that. And during our research, we found out that the successful engineering students have these 5 basic traits. The first trait that we found was they are self-learners. That means they don't like to be told what they need to learn. They see something around, they go ahead, pick up and learn. That is the era that you are in today. Second, whatever they learned, they did not leave it there. They applied it. That means they had a hands-on. That is the H. That's what the S is the self-learner, H is the hands-on. The third thing that we have seen is people who have been successful are always very curious. They have their antennas up, looking around what is happening in the industry. What is the newest technology that you'll not believe? Yesterday, I don't know how many of you, 26, I think, Microsoft released a very beautiful article on how they are going to give machine learning in computers for Mac and Windows on some of the basic machine learning algorithm. I was really surprised, right? I don't know whether you all have even seen that article. So you need to look around what the industry is saying. That is called antennas up. P is a problem solver. The reason today the problem solving everybody is talking about is because we are in an era where people are solving something without knowing what problem is. And that is the biggest problem for us in industry. So when you get into this problem solving attitude, you need to apply what we call in an industry is critical thinking and creative thinking. You will come across workshops in the next 4 years calling design thinking workshop and out of the box thinking workshop, whatnot. The college will arrange something. But remember, identifying a problem is the first thing before even arriving at a solution, right? It is like you going to your 12th standard mathematics exam, and then you don't understand the problem and then you solve it. Whatever you write will be wrong, right? That means you're not going to get the correct answer. So that is not where you want to be. So understand the problem. The final is the entrepreneur. When we say entrepreneur, people think it is all about selling. No, entrepreneur is all about how do you sell your idea the way the other person can understand and you can convince the person. It is another flavor of your communication and a negotiation skill. Why it is important today. You might have a great idea. If you want to have tomorrow somebody come and even listen to your idea and say that, hey, you know what, Viji, your idea was superb. I really like it. That means I really made some impact, because that is where your entrepreneur skill is required. So remember, today people do not have time. They're just looking for the 2 minutes for you to summarize your idea. So how do you really do it? It is all about selling your ideas. It's not about making just the money. Remember that. These are the 5 traits that we saw were present in all the students, I would say, whomever we have featured in the book. This book has around 50 student stories. and crafted beautifully. And these students have agreed to be a mentor for other students as well. So what my suggestion is, you might see change in technology. You might see hardship in your journey. You will find situations where you find yourself broken, but the way you have to bring it all together and put a beautiful golden glue with just keeping these 5 things in your mind. One is S, self-learning. H is a hands-on. A is an antennas up. P is a problem solving. And E is an entrepreneur. But for all of this to do, you need to have something within you. That is called internal transformation. IT is not information technology. Let me make it clear. Unless you are having that willpower and wish and compassion to do it, you will not apply this trait. So first you start believing in yourself that you are an authentic you. You will come across challenges in the next 4 years. You will be broken many times, but you have to assimilate yourself and keep these 5 things in mind, which is SHAPE, shape. Bring your 4 years of journey to a shape, and then you will blossom as a beautiful engineering graduate coming out of the system, rather engineer. I would not even say engineering graduate. You will be an engineer who can possibly give jobs to millions of people, and you will do what you like, and you will be more joyful in your journey. So I want to just close this. This is a start for you, and this is the beginning for you. It's not the end. So every day, look at it as a new start and see how you can make these 4 years of journey in this campus more meaningful, and make it more meaningful for your parents who made you what you are today. So with that, I'll open it up for question and answer. I just kept it very short because it was a half an hour session. I thought I will just keep it short and simple. Yeah. So I'll open it up for questions. I know it is 11:13. So you can type in the questions if you want, or you can ask me the questions. And okay, so Sai Priya ma'am, should I hold on, or what do you suggest I should be doing?
I think we can wait for a few minutes, ma'am.
Sure, we will do that. So type in your questions, because these are the time where you can interact with people. Don't be shy of asking questions. If you are shy of asking questions, you will have a problem even in the workplace. So no question is right, no question is wrong. Every question is a sensible question. So please type in your questions. Go ahead and ask me the questions. Okay, I guess not many questions are there. So Saitya ma'am, what do you suggest? Should we then wind up and give them the time? Is that fine?
Yes, ma'am, you can wind up.
Yeah. So I hand it over to you, ma'am.
Ma'am,
Yes, sir.
Yes.
thank you very much. With your busy schedule, came here and giving us the valuable input for our students.
Thank you, sir. Thank you so much, sir. The
Thank
pleasure.
you, ma'am.
Always a pleasure. Thank you so much.
Thank you, ma'am.
Saitya ma'am, I'll send you my LinkedIn. From Manju ma'am, you can pick it up. Yeah.
Yeah.
Thank you.
Thank you, ma'am.
Thank you.
Thank you,
Bye-bye.
Vijayante ma'am, for joining us. I understand you have given the right dose of guidance required for the budding engineers of this batch. Thank you so much.
Thank you so much.
I'm about to introduce Dr. Lakshmi Narayan, is the Zonal Manager, Design Tech Systems Private Limited. He is responsible for South Technical Support and R&D expertise. Since 2006, his association with Design Tech is noteworthy. Sir, I request you to address our students on this occasion. Mr. Sunil Kumar, are you online? Mr. Sunil Kumar?
Audible? Hello.
Yes, hello.
Yes, ma'am. My voice
Uh,
is audible?
yes, your voice is audible. Let me make a small introduction about you and then you can take over the session.
Yes, ma'am. Yes, yes.
I take this opportunity as a proud moment to introduce one of my students, an alumni of 2013 batch, Mr. Sunil Kumar. He hails from Kanyakumari and he graduated in mechanical engineering from this college in 2013 and obtained his master's in thermal engineering in 2015. He worked as junior research fellow in IGCAR Kalpakkam. After completing this, he joined NIT Trichy for pursuing full-time research. To his credit, he has published 5 research articles in international journals and received 3 Best Paper Award in 3 different international conferences. Presently, he has got postdoctoral fellowship in IIT Bombay. Over to Sunil Kumar to address the freshers.
Thank you so much, ma'am.
Thank you.
And first of all, I would like to thank our college chairman and the dean, principal, HODs, and teaching and non-teaching staff for giving me a wonderful opportunity to give a very small introductory section in front of you all. So, in addition to that, as an alumni, I welcome you all to the engineering domain, Mohammed Sadak AJ College of Engineering. Um, Actually, as Madam told, Sunil Kumar is my name. I'm from Kanyakumari district. I'm the first student, those who completed both BE and the ME from the Mohammed Sadak AJ College of Engineering in Chennai campus. Actually, I graduated in 2013. So after that, I got the opportunity to work in Indira Gandhi Center for Atomic Research, Kalpakkam, for the 3 years Board of Research in Nuclear Science project. That project work was collaborated with IGCAR Kalpakkam and the Mohammed Sadak AJ College of Engineering. So I joined as a junior research fellow in that project, and parallelly I registered my master's degree. So master degree was in thermal engineering. So after completion of the GRF fellowship and the post graduation, I got the opportunity to do PhD in NIT Tiruchirappalli in the Department of Metallurgical and Materials Engineering. Uh, for my for my PhD research work, I have published 5 research articles and another 4 more articles in the under review. So now presently, as Madam told, I got the postdoctoral fellowship in IIT Bombay. So I'm waiting for the joining date. So joining probably will be the next month. So I would like to say some tips to you all, because our college people will tell that the engineering is waste and there's no job market and you will lose some opportunity and you can see you might see in your nearby your home some people will go with mason. Some people will go to the electrical work. Some people will go working in the some small shop like jewelry shop type of situation is now. But actually, I would like to say some few points. Um, First one is how you are studying. It's a prime thing. And how much knowledge you are gaining, and and another thing is which college you are studying. These are all the things of the mandatory field. Okay, mandatory field. Actually, I can say in our college having very good environment. You might see, I am from the same Muhammad Sada college. I entered into the NIT Trichy for my PhD. Now I am entering the IIT Bombay. So that means our college is not a small thing, not a small environment. It is it is giving a enough space to explore your knowledge. It is giving the enough source to enhance your knowledge, and it is giving the very good faculty members to understand the conceptual idea. It indicates that only one student from the private college entering into the IIT Bombay is not a small thing. So it is a collective effort of my teacher and the lab members, like non-teaching staff, those who have taught me in the laboratory work, and my library. So my library contains a collection of books. So I can suggest you should read a proper textbook. It's not like some local other textbook you should not read, because two things you want to do. First one is you should get a job. That is the first one. Second one, you should you should go for the so, higher and higher places. At the time, you should be conceptually you should clear, and you should be like knowledge wise you should be in a pakka. So that thing you will get from only from the standard textbook. So in the YouTube itself, you can type, and you can collect the list of standard books. For example, since I am from the mechanical engineering stream, for strength of materials, I will go for the standard textbook only. So Kurmi only I will read. So in the YouTube, you just type what are the textbook you want to read. That textbook only you have to read. You should not read for the mark oriented. Mark oriented you should not read. So another thing I want to tell, people will tell mark is not a mandatory. Only passing is enough. Like it's not enough. Since this is a COVID situation, I have one small experience. Because last year we applied one scientist post in the CSER laboratory, Bhubaneswar, Odisha. There what happened, since this is a COVID-19 pandemic situation, they cannot able to conduct an examination. So what they did, they scrutinized the application based on the class 10 mark, class 12th mark, BTech mark, MTech mark, and the number of application and the PhD. So based on that, they scrutinized the application, they called for the interview. So what it is indicate, mark also mandatory, mark also mandatory. We don't know in future what is going to be happen. So we should be aware of that thing. Mark also mandatory, and similarly conceptual idea also mandatory. Okay, that thing. So another thing, oh, same what I told just 5 minutes back. In our in my hometown also, nearby my house, people are graduated in engineering only, nearby some college, and now they are going with the mason, and some people are going to the electrical job. Some people are in the some shop as a shopkeeper, they are working. So I am also BTech graduate only. We just compare their level and my level. My level is totally different from there. Okay, even I graduated, and subsequently I went to the Kalpakkam, and I went to the NIT Trichy, and now I am going to the IIT Madras, IIT Bombay. So this thing will come. Only thing the approach and the effort you are giving. Okay, the effort. So in the first year, I'm giving some small tips. In the first year itself, you just decide whether you want to go the technical side or you want to go the non-technical side. Non-technical side, I mean that UPSC examination or your state government PSU examination. You decide where you want to go. Okay. Since our college is in Chennai city, the center of the city, so surrounding us, so many coaching centers are there. They will teach us at free of cost. Okay. So you just plan accordingly. So weekend class, you can go there and you can attend, and you can preparation, you can start now itself. Don't wait up to the final year. Okay. Really you want to go in technical side, like you want to go with a teacher, or you want to go scientist. So what happened, the only one option you have is the gate. One examination is there, that examination called gate. Okay, so how many I don't think all people may not aware of those who are completed engineering, they can work as a scientist. You may not know. There are so many institutes are there. We are recruiting the students from the engineering background only. I can say few. One is like Indian Space Research Organization. I think you might all know ISRO. ISRO, so ISRO and the BRC. BRC means Baba Atomic Research Center. And another one CSIR Lab. And another one Defense Research Development Laboratory. This all that laboratory recruiting BTech graduate or BE graduate as a for the scientist post. For that, they are conducting an online examination or offline examination. Syllabus will be our engineering only. What the subject we are studying in second year, third year, fourth year. These things are only syllabus. So very first year itself, you download the syllabus for the GATE examination and you plan which textbook you want to read and how to read. And our college teachers are very friendly. And they are giving the enough interaction section and conceptually they are very thorough. In the library having enough sources. So I was in my hostel only. I was stayed in the hostel only. So you have another additionally some more time you will get. So you can read. And you can interact with the professor and you can use the library and the only thing, only one examination only. If you crack that exam, next level will be the interview. Interview, you are going to compete with the students, those who are studying from NIT and IIT. So their level is little higher than that you. But if you are performing at least 80% of compared to the NIT student or IIT student, the interviewer will impress to you only. They will take you only because they will judge. So even these students are coming from this background, but he can give the interview up to 80%. So they will prefer you only. So there is no doubt in that. And I can say some people they may come from the Tamil medium background. They might think that how I can going to read, how I am going to understand the concept. But don't worry, student. I am also from the Tamil medium student only. Up to my SSLC, I am in the Tamil medium student. After that only I track change to the English. So in our classroom, like mechanical engineering, but my BTech graduation, the students, teachers are very friendly. They used to speak like understandable language. They will speak very slowly, and they will give an tips how to understand and how to study. And in the English department, the one madam is there, Sai ma'am. See, madam also giving enough effort to bring out you as a fluent English and your body language, everything. The madam will give 100% effort to you. Even she was my teacher. You are in the good place only. Don't worry about the engineering is down and all those things. Don't worry. Still scopes are there. Still opportunities are there. Only thing is in your hand. The way you are approaching. Okay. The way you are approaching. And I can quote one Tripuran that it is called. தெய்வத்துள் ஆகாது எனினும் முயற்சித்தன் மெய் வருத்த கூலித்தன். That means even God also cannot support you. But if you are in doing the hard work sincerely, then the sincere hard work will give you a fruitful life. Okay. So that thing I can point out here. So don't worry about unnecessary negative thoughts about engineering down and people are as a labor they are working. It's not a thing. You don't know about the real ground actually. Real ground is totally different. My friends in my class, we are 48 students are there. In that, some 5 students they did MS in foreign university, different places. They settled there only. Their life is very good. But you are seeing nearby you only. Nearby you is not a life. Okay. So plenty of opportunities are there, and you only thing you have to plan accordingly where you want to go. Whether you want to go technical side or non-technical side. Non-technical side means this is the time to prepare yourself, and you plan. You have make a schedule, and nearby some coaching centers are there, the free of cost. Since our college is in Chennai, it's a wonderful opportunity for us because we can stay in our hostel and we can do the parallelly we can go for the coaching. Okay, so I hope that you understand what I'm telling. Don't think that private college student cannot enter the higher position. Not like that. Even since I was doing my PhD in NIT Trichy, we used to handle the laboratory. So out of 10 experiments, we used to give some 3 or 4 only. But in my BTech time, we used to do 10 out of 10 we have to do, and we have to maintain the manual, and we have to maintain the record, and our non-teaching faculties are there. They will teach nicely, and they will access you to conduct an experiment. And everything you will get in only the private institution only, not in the government institution. Okay, that point only I want to tell you. So the practical knowledge you will get a more idea, and good teachers are there, not like a government institution. I'm not telling that is a bad thing, but since you enter, you have to see the positive side only. Okay, so 4 years going to be in your hand, and you decide, and uh, and what I can tell, I think I can bless you all. Okay, I welcome you all. In the similar way, I am just congratulating you for getting a good opportunity, and being a good engineer in the future. I think I'm closing this section, and thank you so much, ma'am. Uh, Thank you, one and all. Thank you. Thank you.
Thank you, Sunil Kumar, for joining us and for addressing our students. Thank you so much.
Thank you, ma'am. Thank you. Thank you, ma'am. Thank you.
Now I request Dr. Lakshmi Narayan to address the students.
Yeah, thank you, ma'am. I'll just.
Thank you for joining us, sir. Thank you.
Thank you. Please confirm. I'll just share the screen now. Please confirm you're able to see my first slide as scope of engineering and career opportunities.
Yes, sir, we are able to see.
Okay. Thank you. Yeah, sorry. Previously, you just invited, and I don't know, maybe because of the network connection, I lost right at the moment when you invited me. I really apologize for that. And sorry if I'm really facing a lot of the network issue. If anything gets disconnected in between, please bear with me. I'll reconnect again back in a minute. So let's start the session now. So I'll be taking half an hour of the session. My name is Lakshmi Narayan. I'm working for Design Tech Systems Limited as Zonal Manager for Technical Support. So before starting my presentation, let me introduce my organization. So the company name is Altair Hyperworks. It was first originated in the year 1985. So currently we are having 30 plus years experience in the market. And overall strength, we have 2,600 plus employees. Our head office in India is in Bangalore. So we are close to around 600 employees. And this is interesting. You can see this point. Total, we have 8,000 plus customers. So this is where my first slide told about the career opportunities, right? So if you say 8,000 customers, it is like those many number of opportunities will be there for the students to get into these customer list. Now, let's see those 8,000 plus customers. So we have customers in different domains. We have in automotive, we have in aerospace, you can see we have in heavy engineering. Similarly, we have in government and earth and sciences and consumer goods, as well as oil and gases. So overall, if you see over here, so these many, I've just put a short slide of the customers, but the total customers are huge. So it's a huge opportunity for all the engineers to get into these organizations and do the best of their career. So this slide is the one which gives you the career opportunity, is what I would like to tell over here. And now coming up to some of the government customers, like if you are interested basically in delivering your service to the nation. So this is where the nation comes in, like the aerospace or the defense organization like NAL, INTAF, or VSSC, HAL, GTRE, and many of the other government customers. Right. So now let's start with our topic, like what exactly is simulation. So we as an engineers, what do we do is, like we know the physics, we know how it works, we know the mechanism how it does. So I do those physics basically in my laboratory, right? So once I've done my physics in the laboratory, I do n number of tests. So now how do I reduce those number of tests is basically comes to simulation, where I use a computer, or where I use as a tool or a software is what I can call inside a computer. And then I do all those lab setups, whatever I do in the computer simulation is what I, in a simple word, I say it as a simulation. So say, let us see an example of a complex thing over here. This is called a sled test, where a dummy is placed over here, which is similar like a human dummy. And you see over here, there is the patch over here at the knee as well as at the head. So these are the locations where the injury criteria, which is actually happening on a dummy during an accident, is measured to see what is the injury criteria at the knee, what is the injury criteria at the head, similarly at the thorax, or similarly at the hand, is what is measured. So let me run this video, which will give you like how exactly is the actual test works. And the same thing has been replicated in the simulation also. So let's see that. I'll just start the animation. Now you can see over here the simulation has happened. Sorry, the testing has happened. The bottom, what do you see over here is the actual simulation. Okay, so this is the actual simulation which is replicated from the test. So now here, what flexibility I get as an engineer for me is I can do n number of iterations. Say, for example, the head got an impacted on the seat front, and there was a serious damage on the head. Similarly, the leg got stuck into the front portion of the chair. So what should be my design? Or should I need to keep any software member over here? So what should I do next is what I get an opportunity in my simulation while I'm doing a number of trials. simulate it, do a lot of iterations, and then establish how many times it can fold as well as close it. Instead of I doing the same in the testing, which includes a lot of time and the cost. And if I take on the safety factor, this is a case of an aircraft landing on a water. So how do I model a water? Some work of the rotor mechanism. That was on the aerospace. Now coming up to the space, this is a Mars lander. Objective comes in. An engineer starts working on, and then he says, how will I optimize? The optimization is done. He's able to get a stabilized landing. Now, in addition to this, continuation like moon lander or a rover kind of applications which you're doing, where weight reduction is important. Now he has applied all the loads. Now you can see the weight reduction has happened on this particular structure. You can say probably this is weighing around 100 kg. The optimized weight has come down to 80 kg. So totally 20 kg of weight has been reduced. So these are the kind of areas which the current, you can see there is a lot of scope. And now if you take up automotive, you have crash, you have safety, you have kinematics. Now if you take up aerospace, you have landing gear mechanisms, you have composites, then you have optimization, right? Then you have again a crash landing on a seawater, or it can be sloshing. So we have for aerospace, we have vibration, we have fuel labs. We also do have labs for weight reduction, additive manufacturing, and so on and so forth. So that was about aerospace. Now let's see the scope of engineering in heavy engineering is what I mean. Rail is basically your train and those kind of applications. And you can see you also do have opportunities in marine industries. Now let's go with one by one. Let's start with heavy engineering. This is quite interesting. Let me start the animation. Now, in this case, you can see a heavy truck which is actually moving on the road. You will have to see the kinematics of it. You will have to see what is the vibration that is coming on it. You will also have to see how will I reduce the weight of this entire big truck, where I have an optimized design but higher strength. Now, if I take up a train, if a crash happens to a train, the front portion of the train should absorb the maximum amount of energy so that the passengers are on the safer side. Now, this is a virtual simulation where the front impact has happened. Now you can see how the energy is getting absorbed while it is getting crumbled. Now, this is a case of a naval applications. I put it as marine industries. Your objective would be is like if we are working for a naval for our nation, objective is what is going to happen when a ship impacts the iceberg, or if the explosion is happening. So is my ship safe? So these are the kind of application areas where an engineer will have a scope in heavy engineering or in railway applications or in marine industries. Now, if I take up in railways, we have rail coach factories, we have ICF, we have RDSO, we have suppliers for all these railways. Railways is huge, and huge investment is happening in coming near future, specifically for the railway development. So huge opportunities are there definitely for the engineers who are choosing their domain specifically on heavy engineering, rail, and marine industries. So now, till now, how many domains is what we came as? We came up, first one was automotive, second one was aerospace, and now is heavy engineering, rail, and marine. So already we have covered 5 domains. So let's see what are the other areas where an engineer will have an opportunity. Interesting. So now you see even engineering is also used in consumer goods. Can you just imagine like the bottles which is getting packed in a box, you need engineering there. So you need your ideas like how it should be packed. And if you're designing a bottle pack, so what will be the shape of it so that it can consume maximum fluid and it has to be stiff enough. So it's quite interesting, right? So let's see what are the areas that we have an opportunity even in consumer goods. So before going to this, I've seen many users saying automotive, aerospace, but probably an engineer might miss that, okay, I also do have opportunities in consumer goods, This is the slide which is going to explain to you, like, if you do not want your career to be in any of these automotive or aerospace, you still can use your engineering in these fields also. So let me run this video and see how it will be useful for us. This is a case of a drop test of a mobile phone. This is highly important. Any mobile phone that is getting released has to be done a drop test. So we have to do this virtually on a tool. The objective is to see what is the damage that is happening on the sensors. This is first case of a mobile phone. Now this is our daily using, that's of a washing machine. So we have to do this physics. We have to see how much is the vibration, that is noise that is coming on this structure. Whirlpool is the biggest customer who's having around 200 engineers who are working on the design and development of the washing machine. And this is a classic case of egg drop simulation of an egg carrier, which we keep it in our fridge. So what is the impact that is going to happen once it drops at a different angle? So now it's quite interesting, right? So even we have opportunities, even in the consumer goods, if we have our physics nicely built in our academics. So this is another scope. So that's the 6th scope of engineering in our portfolio. Sporting goods also, an engineer is very much required. Now, if I'm designing a bat, this is a golf bat. So what should be the shape of this bat so that once I hit the ball, it will travel at a higher velocity? As well as you can see the jet ski, which is actually landing on the water. So once it lands on the water, what is the damage that is happening on the jet ski? So all these physics, an engineer has to work on it, and he has to see how the system is behaving. So this is our 7th simulation scope for the engineer. Let's see the animation of it. I'll just run it. Yeah, quite interesting. There's a person who is trying to hit a goal, but the ball hits the pole, right? Now you can see this can be simulated over here, which is ball is made of a flexible body and the pole as a rigid one. So those kind of simulations, you can do it. And then similarly, the golf bat, the shape of the bat is what is important. A design is required. So once you design the shape, once you hit the ball, so that ball travels at higher velocity. So this is the animation of it. Now comes the jet ski. This is landing on a seawater. So how do I model it? The coming animation will show you how the simulation works. Here you can see the jet ski, which is actually landing on a water. So how do I model the fluids? How do I model the hull structure? So all these is where our intervention comes in. That's basically an engineer's intervention comes in. Yeah, of course, the 8th one is quite interesting. Even here, we need our presence. Even in medical industry, an engineer is required. So he's not moving out of his area like, okay, in medical industry, an engineer is not required. Let's see where all his area is required. Let me run through this animation. So this is a case of a heart valve. In order to have a smooth flow of the blood, you can see it's got blocked here. The syringe flows here, and then it opens up, and that makes the heart to the blood to flow in a very smooth manner. So whether it can expand, okay, this is again made of a structure. So what should be the thickness of it, and what should be the dimension of it? So all those we design and then validate it. And then if we are working on any complete human body skull injury, so we do the finite element modeling of all these structures, and then we simulate. This is a case of a toothbrush, which we use in our day in and day out. The brush is again modeled with a softer material, and the brown shape is our gums. So if it's too hard, the gums get distorted. So this is where engineer's intervention is required. He simulates all these kind of simulations, and then he sees, okay, whether it's softer or too harder, so that once this particular thing releases to the market, so it's on the safer side. So even in the health industry, an engineer is very much necessary. Right, so this is the current trend, what it's booming up. So people are calling about electric vehicles, people are calling about mechatronics, people are calling about mechanical, people are calling about CFD. So now all these comes in over here. So we call it as electric vehicles. So we all know now the industry is moving into electric because of the norms of the fuel emission, which is going on in every countries. So what exactly is happening is like in our regular vehicles, what do we use is we have our combustion engines. So now all these combustion engines are getting replaced by batteries as well as motors. So motors will be the prime mover specifically for moving your vehicle. So that's the area which is moving in. So now in this electric vehicles, like it's not only mechanical is involved, it involves your electrical, It involves your mechanical, it includes your computational fluid dynamics, it includes your programming. So all those comes in. So now let me just run this video and then I'll parallelly explain. So, motor design plays a very important role in the current industry, which any a particular engineer, an electrical engineer, would try to design a motor specifically for a vehicle, because it's a prime mover which is used for moving your vehicle. So the reason for this is because of the global warming. So every country is having a norms now, strict norms specifically for the fuel emissions. So because of this, all automotive OEMs is looking for another technology, so that is called as electric vehicle. So traditionally, vehicle design which is using fuel will shift completely towards electric power design. So that's the current trend which is going. So now in this case, we do a detailed design, we do the electromagnetic simulation, we get all the electrical forces that is actually coming from the electrical domain. We map it into a computational fluid dynamics, or we map it into a structure, and then we see what is the noise of the motor and what is the vibration that is coming on the motor. So all these parameters is what we study over here. So what is required in this case is we are no more restricting ourselves to electrical. You can see in this, there is electromagnetics, there is a thermal, there is a mechanical, as well as the optimization. So all has to come hand in hand in order to coming into a design of an electric motor. So that plays a very vital role. In addition to this, a computer programming is also required, where you want to control your vehicle if you're working on an autonomous vehicle. So how do I give the controls for the vehicle so that the safety factor comes into the picture? So how do I do all those? So all these things plays a very, very important role in the simulation. Yeah. So I think I'm almost come to my end of my slides. I think I've taken some more time. So this is my last slide. So what I'm trying to give the information over here is the nation still needs lot of skilled engineers. We need a lot of engineers. We need engineers basically to work in the scope of all those domains. So why we need engineers to make all those domains is we need better products, so that you have new ideas, you have innovative ideas. So we need engineers to create those new products. So I am very much happy that you all have joined today. So thank you so much for taking out your time and attending this presentation. So during our career, we didn't have this opportunity basically to know what career should I choose, because career choosing is a very important for any engineer, starting from once he comes to the engineering, because whether should I need to choose my career as an automotive or an aerospace, or into my heavy engineering or consumer goods. So what should be my career is what plays a very important role. So aerospace or a space domain. So all these are my will be your area of interest, which you'll be choosing in your coming future. So with this, I would like to end my presentation. So thank you so much. Thank you so much for your time. So I can keep the questions for, I mean, if you have any questions from my side, I mean, from your end, you can please ask the questions. So any questions from the students or from the faculties? Yeah. Yes, sir. Thank you. So any questions from the students or from the professors? You can unmute yourself if you have any questions, and you can ask me. Or if you have any questions, you can also type your questions on the chat window. Yeah, I think I didn't get any message in the chat window. Or if you want to ask verbally, you can also unmute yourself and then you can ask many questions. I hope the message was clear. Like the career opportunities is what was shown here for all the engineers who are present here. Like you can choose your careers on all those 8 areas which I just showed. It can be on automotive, aerospace, or heavy engineering. So it's wonderful opportunity for you guys. So to check on those areas and then you can start working on it. Right. Any questions from the audience? Yeah, Priya ma'am, I think
Yes, sir.
I'm done with my presentation. So if any
Yes, sir.
questions is there, I'll be happy to open to take the questions.
Okay, okay, sir. Okay. So thank you so much for joining us and giving us a clear idea regarding the scope of engineering in various fields. Thank you so much for your clear presentation once again. Thank you.
Thank you, ma'am. Thanks.
It's a pleasure to introduce another alumni of 2005 batch. He received his bachelor's from this college in the year 2005 and obtained his master's in business administration in 2012. He is a 3D vision expert, digital transformation and industry expert, and a technology consultant. He is also a specialist with complete experience in industry automation, sales at automobile vehicle, consumer product, and electronics. Presently, he is the head of sales at Camtech India, Pune. So, over to Krishna Kumar to address our students. Welcome, sir.
Yeah, hi guys, and welcome to the future engineers who have joined Mohammed Sadak AG College of Engineering. Um, See, just to say about the academics. So we had a good academic because we had a good lecturers in Mohammed Sadak AG College of Engineering. They have given the best practice, which is will be implemented in the industries based on their technical input and the best practice which has been followed in industries. It gives us the confidence go and face in the real time projects and even the real time applications. So let me give some highlights. This is my suggestions to the joiners. It is just focus on the practical things because the college which gives is the theoretical knowledge, and you guys need to focus more on the practical things, so which is being followed in the industries and also in the I'm totally into the core industries because I done my engineering in electronic and communication. So I choose the field core engineering. So most of the people who are also doing electronic and communication are jumping into IT core. Okay, no issues. So if you are interested in the IT field, you can always go for IT vertical. But my suggestion, my input is, because your core strength is electronic and communication, it is totally into the core industries. So it's my input and suggestion is you choose the field of core industries, because you can learn more compared to the IT vertical. For example, you can also learn things in process industries, discrete industries, and also the PLC automation and robotic automation. You can also learn some IoT industrial IoT applications. So it is my suggestion and my input is to focus on the best practice of the core industries, and you can learn more things in the industries, so you can always grow faster. So if you are going, for example, if you are going for the IT field, you will be uh, you can able to develop your skill set only in the maybe a Java or HTML or Python or Halcon. Okay, but the same platform, Halcon, Python, and also C++, you can also become as a programmer. You can also become as a programmer or a development design engineer. So you can also do the programming for the robots. So robots, PLCs also require the programmers. So it is not only in IT field, the programmer will be utilized. So my input is, if you develop your IT skills like Python, again I'm saying HTML or C++, C sharp, or whatever maybe HTML, whatever maybe. So it is not only the IT is the choice. In core industries, again I'm saying you can also do programming for robots and also for the pneumatics, and you can do program for the PLCs, and you can do programming for the IoT applications. So my suggestions to the freshers is, whatever the theoretical knowledge is being transferred to you, grab it and make yourself strong on the theoretical knowledge, which will give the entry to the industries. But the thing is, with that theoretical knowledge, you cannot able to face the real time applications. So you guys need to develop your additional skill sets on like PLC programming and also with the robotic programming. My suggestion is, while you are doing your courses, engineering degree, you parallelly focus on the additional courses like robotic programming, because in core industries, robotics are becoming more, what to say, even in the COVID, if you see, most of the things are, which is non-touchable. So all the productions, people's the peoples are implementing the without resources, human resources. Everyone are implementing the robots, and also they are implementing the high level automation without the involvement of the operators and the also the engineers which is on the line. So it is better if you develop your skill sets on core industries. You have a lot of opportunity. There are a lot of open opportunities in the industries. So this is my suggestions. And for the engineers who have joined with the average percentage of mark, my suggestion, if you are not strong on the academic, it is better you focus on the additional courses. From now you learn some mission vision programming languages. So it is just graphical languages, Halcon and Python. So you parallelly develop these skill sets with the real time courses. So that will help you once you complete your degree. That will help you to uh, enter into the companies. Like for example, there are a lot of production companies. If you take, let me give the insight about the core industries. So if you take automotive vehicle, so there is Hyundai, there is a Renault, Nissan, there is Royal Enfield, and Maruti, Toyota. There are a lot of manufacturing companies, and they are looking for the well skill set engineers, for project engineers, engineering department. See, let me say what are the departments they have. They have a project department, they have engineering department, they have a production department and maintenance department. So there are a lot of departments. Okay, so you have a lot of doors you can go and knock if you focus on the core industries. So IT field, again I'm saying IT field is also a good field, but you cannot explore more. So that is my suggestion. You can always do one programming day to day. You can do everything will be the same programming. But here the hardware involves, and also the software involves, and also the different applications with the process industries, and also the discrete industries. So that's it from my side. uh, I'm not, because still I'm on driving. So that's it my from my side. That's it from my side. My suggestion is, guys, you parallelly develop few core industries courses. You learn core industries courses which will give the real time applications, and also you can able to go and face the job when you finish or complete your degree. Got it? So that's it from my side. I'm not taking more time. That's it from my side, ma'am. Thank you.
Yeah. Thank you, Krishna Kumar, for joining us and guiding our students on this Freshers Day. Thank you so much.
And guys, students can take down my email ID and mobile number if you require any guidance on how to develop your additional courses, to develop your skill sets on core industries. Always you can call me so I can guide you. My mobile number is 91766 Okay, and my email ID is krishshadi@gmail.com. So that's it from my side. All the best for the future engineers, and also for the professors and the lecturers for the MSAGC.
Thank you. Thank you so much. Now I'd like to introduce Mr. Jay Kumar, an expert in VLSI. He received his bachelor's in electronics and communication engineering from Satyabama University and master's by research from Anna University. He started his career in designing GPS receiver for satellite and also worked on various chip design products like microcontroller, GPS receiver, and many more. Also, he has mentored many college students to get VLSI job. Sir, I invite you to address the students.
Thanks, madam, for the introduction. Could you please provide me permission to present PPT?
Yes, sir, you are welcome.
So the PPT is visible?
Yes, sir, it's visible.
Yeah, so welcome students to the college, Mohammed Sadak Engineering College. And so here I am going to present about the VLSI opportunities, job opportunities, and what are the how the subjects are related to each domain. I'm going to explain about electronics. So is the PPT is visible or is my video is visible now?
Yes, sir, it's clear. It's clear.
So PPT is visible to you or my video is visible? Which one is visible now?
PPT is visible.
Okay. Okay. Um, okay. This may be more focused towards electronics and electrical students. Maybe other students, they can also understand what is going on in the chip design industry. I'll give a overview. I have taken this. This is a tear down picture of. Is it visible now? Hello. Hello.
Yes, yes, sir.
Is it visible? Full screen.
Yes,
Yes,
sir,
sir, it's
visible.
visible.
Okay. So I have shared the tear down of a smartphone here. And so this is one of the latest smartphone. And if you see here, so each one is a chip. This one is chip, and this one is chip. So each one is a chip. And if you see here, it's mentioned as front-end module. Skyworks is a company name, and front-end module is a in a phone. When you receive a signal, this module will be the front-end module because that's the first module. Okay, and there is other module like a transceiver. When you for a transmitter and receiver, this chip is used. Okay, this chip is used for a baseband processing. After you receive a signal, to process, you need to have one more chip, which is from a Intel company. And this one is for a near field communication, like what we have, Bluetooth, Wi-Fi, like that. This is like one more a wireless technology, which is a near field communication. And this chip, this is from ST Microelectronics, and this chip is a microcontroller. This is for what purpose? It is for a smaller applications. Like for example, this microcontroller will be normally it will be used in a fridge, washing machine. This chip will be used anywhere. For any small usage, this chip will be used. And if you see here, Wi-Fi and Bluetooth wireless. So this big chip is for a Wi-Fi and Bluetooth. And this is a company called Murata. Recently, they have opened a design center in Chennai. Chip design center in Chennai. Murata has opened it. Okay, and this module is mentioned as a PAM, which is a power amplifier. Okay, how does this power amplifier? You can imagine that you are not getting. You will tell that you are not getting a signal. Phone signal is very weak. So that is one. That is for receiving. And while transmitting, you have in your phone you have to increase the power of the signal to transmit. So when you increase the power of the signal, it will go high, and that's where people tell there's a huge radiation. In this phone, there is a huge radiation. So don't keep the phone nearby close to your face. So that is because of this chip. This is the chip which is creating a more radiation. But why we need this chip? If you don't have this chip, it will not increase the power. After you increase the power only, we can transmit. So we have to increase the signal strength to transmit, but that also should be in a limit. That is why if you see in any low cost mobile, they will have this power amplifier, but it will be increasing the power very high. You'll feel like okay, it is getting the signal is working fine. I am getting a good signal in the low cost mobile, but it might be sending a more radiation. It will be harmful also. Okay, so this when you buy a mobile, you can look for these options. What is the power amplifier rating? Normally, you look at what is the pixel of the camera, those things. But now onwards, you look at what is the rating, power amplifier rating in any mobile. Then you will understand what is the meaning. So, everyone following it, or any questions here? Am I going very fast? Hello? 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 Hello?
Yes, sir.
Is it audible? Everyone is able to follow what I am telling. Any questions? Students, yeah, students, please ask any questions if you have in this. Why I have taken this picture is since everyone know about the phone, I want to take phone and then tell what is inside. Okay, so if any questions, you can just ask me. Okay. So here this chip is for a audio. For audio, we need to have an audio video also in the phone. So this phone is meant for a audio purpose. This chip, this is a Apple chip, and this is the Intel PMIC, meaning power management IC. So we have all this chip 1, 2, 3, 4, 5, 6, 7, 8 chips we have. For this chip to we need to provide a supply. Normally, what supply we'll give in our home, we get a 230 volt. Okay, and when you put the adapter adapter will convert 230 into 5 voltage. So when you connect your phone to the adapter, you will get a 5 voltage something. But these chips, no, this chip, there are chips which works at 1 point voltage, and this chip will work at 2 point voltage. So there are different need, different voltage requirements. So with 5 voltage, we cannot make it work. So this chip need only 1.2. That means you need to have a system where it takes 5 voltage and generates 1.2 voltage, 3.3 voltage. Like that, it should generate. So this chip, PMIC, this means power management IC. It takes in 5 voltage and then generates different voltages, 1.2, 2.5, 3.3, different voltage. And this supplies all this. This block supplies all these chips. And if you see here, this small modules, these are called capacitors. And these are small modules or resistors. You will study this component. These are basic component in any circuits: capacitor, inductor, resistors. So this you will study in your subjects. So I'll move on to next slide. So similarly, if you see here, so for the same phone, I'm telling the other side of the what are the chips it has. It has different power management IC. If you see ST microelectronics power management IC and Apple Beam power management IC, and there is one more Apple power management IC. If you see here, DC-DC converter. This is also power management module and audio codec. And here is you see USB Type C. This is from a company called Cypress. Okay, and the NXP chip, NXP company, and its chip is for a display purpose. Okay, and this one is a Apple processor, bigger processor. It is for main processor. Just one second. Sorry, I got an emergency call. So now the PPT is visible. Hello?
Yes, sir, it is visible. It is visible, sir.
Yes. So this picture we saw, and this is a different type of one more different smartphone. And here also if you see power management IC, pressure sensor, voltage regulator. This is like a power management IC. And this one is a audio amplifier and power management IC. And this is a application processor. So if you see Murata, this one is same front end module. This kind of a power amplifier. Power amplifier like a good one is like this one is power amplifier. Industry standard power amplifier is from a Skyworks. Skyworks is the one who manufacture very good power amplifier. It will not exceed the limit, which will not affect our body. So Skyworks is the best power amplifier in the world. And if you see here, this is one more picture. Okay, I don't want to go more in this. Maybe I can tell about this one is a Broadcom GNSS receiver. Anyone know about a GNSS receiver? What is the GNSS? Any idea about GNSS? Anyone used it? Hello? Hello, students. At least it's good. Anyone respond? Hello. Hello. So, okay, let me move ahead also. So, GNSS meaning you might heard about the GPS. Have you heard of GPS? Hello.
Yes, sir, you're audible, sir.
Yes, yes. Have you heard of GPS?
Yes, sir.
Yes. So, anyone heard about GNSS? Anyone heard about GNSS? Okay, so I'll explain GNSS meaning Global Navigation Satellite System. Okay, this is a common word, but the GPS is the satellites launched by a US. Okay, so whatever we are using now, GPS, it is from the US navigation system. So that is GPS. So and we currently India has also started different navigation system. It is called the NAVIC, NAVIC. So GNSS meaning so it's a common term, and if with this receiver can support GPS. And for example, Europe also sent a different satellite for a location purpose. That is called a Galileo. So this is a common terminology which says it can find a location. Okay, so so just for understanding, I'm telling GPS, whatever we are using now in the phone, that is been those satellites has been launched by US. It is US based positioning system. Okay, so India recently has launched satellites for India purpose only. That is called as a NAVI. Okay, so these are all different models. I'll move on to this. Okay, and now if you see here, so I showed so many chips inside a phone. Inside a one phone, there are at least 20 different IC chip is present in a single phone itself. So when you get a single phone on hand, it needs to go through many process, many chip design. It's not only one company. If you see here, so many companies are doing different models, different parts, and it's integrated and sold as a one product. And if you see here, so these are the I'm just giving the overall cost of a high cost mobile. You see here, each application processor modem. This is for a 2G, 3G or LTE modem. What is the cost of the modem? And battery. This is like you have a battery store battery in the phone. How much it is cost? So this is a rough cost of a one particular phone. Okay. So this is a split up cost. So this will vary based on the different products. Okay. And now I am moving to a next slide, which is so this one is I'm showing the one single chip. Whatever I showed in the previous phone, there were around 20 chips. Now I'm just showing a single chip. Okay, so this is a single chip, and these are all pins connected to it. Okay, so now what is inside this chip? Okay, we saw phone has 20 chips, and I have taken one chip as sample. Inside this chip, it will be like this. This is a layout of the inside that small chip. This is present. Okay, if you see here in that chip itself, there's a different logic. GPU meaning like you can say, if you know about a CPU, so GPU is a general processing unit. Likewise, different modules are placed. One module is placed here, one module is placed here. Like that, it is arranged. Okay, and this small blocks are memory. We are using USB like a memory chip, memories. So like that, inside the chip also there will be memory. So these color ones are memories. Also one more snapshot. This is also one of the layout which is inside a chip itself. And if you see here, these are all memories. 1, 2, 3, 4, 5, 6, and this is also memory. And this is a block is called analog to digital converter. Okay, PLL, oscillators. There are different blocks, and these small regions are we can say we normally call it as a standard cell or a digital circuits. Digital circuits meaning This contains AND gate, OR gate, small circuits, or inverter. Okay, small. These regions. These regions will contain small. So, for example, in this region, how many cells will be present means it will be around more than 10,000 standard cell. 10,000 AND gate will be present in the small region. Okay, then you think about how much will be present in this region. Okay, so to do this, normally when in the early stage, 40, 50 years, they usually place this manually, but they will not have a more standard cells in the chip. They normally have a 100 standard cells. They manufacture 100. You would have heard about 7400 NAND gate. So those has like 4 or 2 NAND gates. So those are placed manually and then manufactured. And after going 100 gates or 500 gates, that time also people worked with the manual approach. Manually they'll place the AND gates and then fabricate it. Now these are like, for example, if I say 1000 itself here, and this full region will contain a 10 lakh of gates and gates. Okay, we cannot place it manually, so we need to have a softwares to do the placement of it automatically. So it will do placement here automatically. Okay, maybe I'll show what is inside, how the layout, small layout will be look like. So this arrow, wherever the arrow points out, this region, how it will be. This is what. So this is a small layout of a inverter. Okay. So this one is a circuit of the inverter. Okay. In the previous slide, it will be like this only. But what is the function it does? What is the work it does? Is it does work like this. What is the function of this is inverter. When you give a 0, it converts to 1, or when you give a 1, it converts to 0. It inverts a signal. I'm giving it just an inverter circuit layout here. So everyone is following it, or any confusion here? Any questions? Hello. Hello.
Sir, audible, sir.
Yeah. So
Right.
students, it's see, we are here to explain what is chip design. So if you have questions, you can ask here. I can explain here. Okay. Okay. I'll move on to next slide. And how this chips are made. What is the basics of chip? Anyone know about it? How chips are made? Okay, let me answer. So chips are made based on the silicon. Silica meaning it's a sand. From sand only, these chips are made. Normally, people will tell sand is not usable. Like general people used to scold with it's mud. But here, this mud has been converted as like very fine tuned with different process, and then it has been converted to a chip, and that means we are giving a more intelligence to the sand. And think, see, this is just a sand, but if you see in a phone, there are 20 chip, and each chip is made of metal connection and the silicon. So if you see, all the chips are made of silicon. So till now, everybody able to follow? Okay, let me move on to next slide. So here I am just mapping chip design with easy subjects. What are the subjects we have and how it is related? Okay, so we studied about phone, how many chips are present, and chips, how it will look inside the chip itself, and what is the basic circuit, and how the that I have done. And now we look at how it is relevant to our subjects what we are studying. Okay, so if we see here material properties and semiconductor physics, what we are studying here in this, we study about the properties of the silica, the material, what we are using for a manufacturing purpose. Okay, so that is being studied in a subject called physics for electrical engineering. And this AC DC circuit design, voltage distribution. So we saw about the power management IC. What it is doing, it takes a supply voltage, higher voltage, and reduces to different voltages, and then distributes the voltage. Okay, star delta conversion. I take one, and it goes like star kind of connection. Okay, so this all been studied in the subject called circuit analysis. And so nowadays, the technology used for the manufacturing of the devices is like it's a basic is transistors. And previously we have used BJTs, and now we are using a FET transistors. Sorry. So I'll just stand here. So transistor, that is the basics of the any device. Okay. Previously we have used BJTs. Now it is a FET, which is like a MOSFET, MOSFET, MOSFET. And recently we are using PMOS and NMOS, and which is called as a CMOS, complementary MOS. So the study of any transistor devices, it is in electronic devices. Okay, and there is a subject called data structures. What do we study in data structures is, so I have told about the layout, for example, this layout and this layout. So these are all like, in this I told like 10 lakh AND gates are present. So I cannot to manually place the standard cells. So how I need a software for doing this. So that software is called as a EDA, electronic design automation. Okay, so any chip design software that is named as a EDA, electronic design automation tool development. So for that, if you want to get into that job, EDA tool development job, data structures, you need to study data structures subject. Okay, and for any amplified design, you have a signal and you need to amplify the signal. That is being studied in the electronic circuits one. And signals and system, there's a subject called signal system. So what is a signal? So you having a audio signal, video signal, any like image, those kind of signals related stuff you will be studying in the signals and system. And this we were talking about the gates, AND gate, OR gate, and flip flop. This you will be studying in the digital electronics. Okay, and there is a subject called probability and random process. So in this you will be studying about a correlation which is used in GPS, LTE modem design. So this all you will be studying in the probability and random process. And you know GPS is very important portion in any chip design, not only any phone, not only in phone. In upcoming years, you will find a GPS in many products. Okay. And electronic circuits too. So you will study DC-DC converters. Okay, so this been I showed in one of the product DC-DC converters they have used. Okay, and the other subject is communication theory. Here you will study about the AM, FM. You might hear about the AM radio, FM radio. So what all this? It's a AM amplitude modulation, frequency modulation, and PSK, spaceship key modulation. So you will study about different modulation techniques in the communication theory. So why modulation is required? See, you have a message, and if you need to transmit a message to a longer distance, so it cannot go on its own. So you have to mix with the carrier signal, carrier which is a higher frequency, and then send it to a longer distance. So that is the modulation. So for example, I'll give an analogy. So you have a paper and you just want to throw it to some distance. So paper, you assume that paper is a message. You want to throw it at some distance. So that means paper will go at, for example, it will go 10 meters only. So if you want to throw the paper to a longer distance, 50 meters, what you need to do? You can add a weight to that or stone, and then uh, mix it with like, or fold it with the paper and then throw it. So it will go far away. That means you are having a heavy weightage to the message, which is that stone. You can think about a carrier signal. Carrier signal is with a higher frequency. Okay, normally message signal will be at a lower frequency. So to transmit a signal low frequency, you need to have a high frequency modulation. Modulation is this: to carry the signal, you do a mixing of a high frequency signal and then transmit. So those all you will be studying in the communication theory. So next subject is linear integrated circuits. So here you will study about a PLL, phase lock loop, ADC, digital to analog converter. ADC is analog to digital converter. Why we need analog to digital converter? Whatever sound we hear or whatever we are speaking, these are analog. Okay, but internally in the chip, all the processing is done based on the digital only. So you need to convert analog signal to a digital, and then digitally it will be processed inside the chip itself. So those will be studied in the linear integrated circuit. And in any phone, you have a transmitter, receiver. About transmitter receiver study is present in the digital communication. And you need to study about the filters also. So you are getting a call, and you only should receive the call, and no one else should receive the call. That means you should need to, or you should not hear someone's talking also. See, that means you need to have a filter. Okay, filtering others information is called filters. So removal of unwanted signals, that is being studied in the digital time signal processing. So filter design, FFT, fast Fourier transform. This will be studied in the digital time signal processing. And processor architecture meaning, I'll say, okay, so this is a bigger processor. This is the main processing. That means it take all the information, for example, touchscreen information, phone information, camera information, all information it takes and then process and then send it back. So that is the heart of the any product. And so that one is a processor architecture that is being studied in the computer architecture. And next subject is communication networks. Here we study about whatever the communications like USB or Ethernet, Bluetooth, Wi-Fi. These are all communication networks that will be studied in detail in communication network subject. And I told about a microcontroller or microprocessor from ST Microelectronics. So to study about that, you need to learn microprocessor, microcontroller, and then standard cells. This like all this put together, you will study in a VLSI design. Okay, about standard cell, flip flop, AND gates, OR gates, you will study in VLSI design. And in wireless communication, you will study about whatever the channels. So I transmit a signal, it goes in the air and someone is getting it. And for example, I transmit a signal, that signal hit on a wall and then reverting back. Okay, so that means signal is not going directly. It is hit by a big building and then it is reverting back. So it's kind of multi-path. Okay, and wireless channel meaning air channel, because if you see in the air, so many phone connection signals are transmitted. So what is the behavior of wireless channel? How wireless channel will work? That is being studied in the wireless communication. Okay, and I was telling about a carrier frequency, high frequency, that is called as a radio frequency. So study of those high frequency or radio frequency is being done in the transmission line and RF systems. Okay, and all this Now I have made all by studying all this. You will be able to design any chip. But after that, we have to integrate that chip inside a board itself. So that board, for example, so these blue ones are called board. Okay, so you have different chips. Now you have to integrate and then put as a single product, and then you have to sell it. So that comes as a embedded embedded real-time signal processing. So integration of all the chips and then making it work is a embedded real-time projects. Okay, so this I have mapped a few of the subjects only, not all subjects, to how it is how all the subjects are related to the chip design. Okay, maybe you can also take a snapshot of this what I'm saying, so that when you're studying you will know where it is used, how it is used. Okay, this is with the simple example of phone itself. You are having a chip design and these are related. So that's what is being given in the last these two slides. Okay, and here opportunities. What are the opportunities we have? And if you study all these subjects, and you will get into this kind of job like algorithm development. For example, to process a signal, you can think about different algorithms to process a signal. And then communication expert. Expert meaning now currently it is like 4G network, and there are 5G network also is going to come. Okay, so this wireless communication will be established in many of the products. Now we have this wireless communication modem in phone or a TV, not many products. But very soon we'll be getting a wireless modem in small products also. It's called as IoT, Internet of Things. You can Google and study what is Internet of Things. That means all the products will have its own modem, its own 5G chip itself. All will have the SIM card. Inside the SIM card, there will be SIM card slot, or like that it will work automatically. It will be connected. For example, I have you can say like a tracker chips. So one cycle manufacturer think that he is having a tracker chip inside a cycle itself. So this cycle, if you might be seeing metro station, there are cycles. In that cycles or bikes, in that they have kept a GPS. Okay, so someone can take the cycle and then again drop the cycle at the right place where they have given in the parking slot itself. So sometime before, one person has taken the cycle and throw it to his house itself, thinking that no one will find it. Now what happens is, so the cycle itself has a GPS. That means it can calculate a location, and then it has its own modem connection, 3G network. So it sends the information to the overall office, and then those people understand okay where the cycle is. They directly come to that place and then took that. So this is one example where GPS is used, where modem is used. So that way communication is very growing very fast, and that too earlier this communication related work was not present in India. So now it is growing, and Indians also contributing more on the communication related products. And this is like signals engineering. Okay, so this is about understanding about the different types of signals, and this also comes under the communication networks. And then after you do development everything, you need to go to convert that as a coding. So that is called a Verilla coding. It's similar to the C coding. This Verilla coding is for a VLSI chip design. After you do coding, you have to verify it, whatever you have done, and you have to see whether that coding is working or not. It has been done by verification. And after you do verification, there's a process called layout design. Layout design meaning this is what layout design. So you have to do this small will be done by software itself. But bigger blocks you have to arrange all these, you have to manually keep and then arrange. Okay, step by step we have to see, for example, this memory will be connecting to here. This memory will be connecting to. So you have to arrange how the connection is. You have to arrange block by block where how the connection. And for example, in the chip USB port will be here. Okay, likewise, you have to see how this chip will be used in the overall product. Likewise, you have to place the USB port in the layout itself. Okay, so that is being done in the layout design. Analog design meaning whatever you study in the circuit design, amplifier design, DC-DC converter design, that will be done in the analog design job. And what is package design is, this is a chip layout, and that layout will be made as a this one. This is like package. So doing this itself a bigger job. That is called as a package design. Okay. And next opportunity is board design. Board design is, for example, designing of this black board or this blue color. Blue color. Blue color is a board, but designing meaning where to place this chip. Now I have in a phone I'm using 20 chip, but how to place it? And now everyone is looking for a slim phone and smaller phone. Okay, that means you have to arrange the blocks, all the chips, so that you will get the compact phone and thin phone. Okay, so this is called a PCB design. Placement of this capacitor, ICs, where it is done. So this all been done by PCB design. That is called a board design. PCB meaning printed circuit board design. Okay. Now you have designed a board and then you have to validate it also. You have to, chip is manufactured, you have to validate the chip using a silicon validation. This is one kind of opportunity. And then what is reliability qualification? So I have manufactured chip. How many years this chip will work? So we have to test it. Okay, because without testing, see, you might be knowing about any product you buy, they give about 2 years warranty, 2 years guarantee, warranty, 3 years. How do they give? They know, they would have tested many times whether this product will work for 2 years. Okay, after 2.5 years, it may fail also. They might have tested. Okay, that means within 2 years, it definitely will fail. Okay, so within 2 years, definitely it will fail. Then they will decide about, okay, they'll give 2 years warranty. Okay, that is being tested reliability. How many years this chip will work? Okay, that's called a reliability qualification. Then only they say 2 years warranty for the phone. Okay, some years back, one product has told that 3 years warranty. And if see, most of the phones were failed working after 3 years. Because the chip manufacturer would know about after 3 years it will fail. That's why they gave a warranty as 2 3 years only. Okay, so that how they give a warranty is based on this reliability qualification testing. And then product testing. After you have put all the chip in a board, they do the product testing. And then embedded testing. Okay, this is similar to product testing. Product design, and then there's a specific called product testing. Product testing meaning you integrate all the chip is working, and then make it as a phone and then test it. That is called as a product, overall product testing. And if you make a phone, it will not work without a software. Okay, there are many software design needed to make the phone work. So software design job is there. And in software design also, there are so many app development that everyone will know about, Android app or iOS app. So those have been opportunities present in this. That means application development. Okay, so these are the opportunities present in chip design. Okay, so that's all I have for today's discussion. Any questions on this? Any opportunities? Anything? Any people have a doubt?
Ready?
Hello. Yeah. So that's all. So anyone have any doubts? Anything more understanding is required? I can explain. Hello. Students, it's you can ask questions. So I can explain here. Not only here, I'll often come to your college and then I'll tell how this chip is in industry. Okay, so not only this forum, I'll be getting connected with the college. I'll give more inputs how to grow also. If you have any doubts, maybe you contact the professor and then they may tell me and how to proceed also. Okay, so note down your questions, what to study. I have given each subject, how each subject is important. I have given the details. So that means you have to study all the subjects. All the subjects are used in the industry. Nothing is wasted. Okay, so you have to concentrate all subject, understand and study. It's not like just reading the book and then getting the marks. Okay, getting the marks will not be useful anywhere. So you need to understand and then study because each subject is used. Okay, if you have a good understanding of the any way like electronic circuits, you can shine very well. Okay, getting job is very easy, but knowledge you have to gain. Without knowledge, it's tough to get a job. So at the start of the engineering itself, we are giving this information so that you know what for I am studying this subject, what for I am studying probability and random process, what for I am studying signal processing. So now you know what is the how it is related, how it is related to your phone. Okay, so that will help you to study better. Okay, any questions? Hello. Okay, madam, that's all I have to discuss. Thank you, everyone, for joining the discussion.
Yes, sir. Thank you so much for joining us and have very clearly elaborated on the opportunities and chip designing and all other aspects related to the field of electronics. Thank you so much, sir. Thank you for joining us.
Okay.
Now I request Dr. Balakrishnan to propose the vote of thanks.
Good afternoon to all. On behalf of management, principal, HODs, staff members, and students, I would like to thank today's chief guest, Mrs. Y. Jayanti, IBM Global Services India Limited, Bangalore, Dr. Lakshmi Narayanan, Altair Product Partners, Design Technology System, Mr. Sunil Kumar, our alumni, 2013 batch of Department of Mechanical Engineering, Mr. Krishna Kumar, our alumni student, 2005 batch of Electronic Communication Engineering, and Mr. Jay Kumar of VLISI Expert for their wonderful address and advice to our students. Definitely, your words will be very useful to our students' future. I would like to thank our director, principal, administrative officer for their continuous support for making this event very grand success. I extend my thanks to head academics, head administrations, and head COE and research, and all HOD staff members, technical staff members who are supported directly and indirectly for their wonderful events. Last but not least, I thank all the first year students and their parents for joining us with these wonderful events. Once again, I thank you all. Thank you.
Thank you, sir. Now we have the national anthem.
शुभ नामे जागे तव शुभ आशीष आशीष मांगे